In Lesson 20, we're going to look at writing and graphing inequalities in real-world problems. So there'll be a lot of terms that we'll see here that we'll have to kind of remember what they mean. So if we look at our verbal statements here, we're then going to use inequality symbols to rewrite it and then graph that on the number line. So the first one says Caleb has at least $5. So if you have at least $5, that means you would have $5 or more. So at least means greater than or equal to. So anytime you see the words at least, you should know it means greater than or equal to. So I'm just going to kind of write this inequality using C for Caleb, since that's who we're talking about. He has at least or greater than or equal to $5. And I'm going to leave off the dollar piece because we're just looking for the number here. So if Caleb has greater than or equal to 5, remember if we have this line underneath, so whether it's greater than or equal to, or if it's less than or equal to, that means a filled in circle or closed circle at the number. So at 5, I'm going to put a closed in circle. I'm looking at Caleb's amount being greater than or equal to 5, so that would mean I would want to shade the numbers greater than 5. And this could continue on because he could have more than $8 as well. Also remember, if our variable is first, the symbol will show us which way to shade. And that symbol is also seen right here at the end of our number line. So if we look at letter B, it says Tarek has more than $5. So hopefully we all know that more than is just another way of saying greater than. In this case, there is not a line underneath it. So if I have greater than or less than, remember that will be open circle when we get to our graph. So since he has more than $5, that means he does not have $5. It does not include that $5. So he could have $5.01, but he doesn't have $5. So for my inequality, I'll start just in the same order it's written here. So Tark, or T, more than 5. Okay, so for graphing this, again, since it's greater than, I'm going to put an open circle, so it does not include the 5, but it would be anything greater than 5. So that does include any decimal, since it's money, any decimal from $5.01 up. Okay, looking at the next one, Vanessa has at most $5. So what at most means is that she would have less than or equal to $5. So the greatest amount she could have is $5, but she could have any amount less than that. So again, when I go to write my inequality, I'll just write in order. V for Vanessa, at most, less than or equal to 5. Since we have that line underneath, that means at 5 we would fill in. And I'm going to shade anything to the left or less than that 5, and so on. Now this could mean negative amounts because she could owe people money. So that is a possibility as well. So it is okay to shade that to go on further down the way. Okay, letter D says Li Chen has less than $5. This one's pretty much spelled out for us because less than is just the less than symbol. So here, Li Chen has less than 5. Maybe I'll use a lowercase l for Li Chen, has less than 5. So again, this does not include, there's no equal sign underneath the 5. So that means she does not have $5, but anything less than is open for possibility. Okay, so there are some examples of how to take a statement in words, rewrite it as an inequality, and then graph it. So the next set of examples is going to bring in more than one inequality. So this one says Kelly works for Quick Oil Change. If customers have to wait longer than 20 minutes for the oil change, the company does not charge for the service. The fastest oil change that Kelly has ever done took 6 minutes. Show the possible customer wait times in which the company charges the customer. So if I'm looking for a wait time, I'm going to use W for wait time. The first one says if customers have to wait longer than 20 minutes for the oil change, they do not get charged. So that would mean anything greater than 20, they would not get charged. We're looking for when they would get charged. So if it's longer than 20 to get charged, that would mean wait time less than or equal to 20. Okay, so it could include 20 minutes. So if they get done in 20 minutes, that's included in getting charged. If it's anything further than 20 minutes, they don't get charged. Now, the other piece to this is that Kelly has, the fastest one that she has ever done took 6 minutes. So what that means is that you would have to wait at least 6 minutes. Okay, so that's the very least amount of time. So at least, remember, would mean that she's done it in 6, so it could be equal to 6, but typically it's greater than 6 minutes to have one done, since that is the fastest time she's possibly done. So now if you'll notice, we're using that same variable for wait time. So what I'm going to do is I'm going to take that same variable and write it down. Since 6 is less than 20, I'm going to put 6 in front of that variable, and I'm going to put 20 on the other side of that variable. I'm going to write this as one statement. When I look at the wait time being less than or equal to 20, since the variable is to the left of the 20, and here the variable is to the left of the 20, the symbol will stay the same, so wait time less than 20. However, when I get to this piece, I've flipped the order in which I originally wrote it. So what I should do is pay attention to where my open sign is and my point. Notice it's pointing to the 6. So I'm going to want my symbol to point to the 6. And of course, we also have to include the line. So this is how we would incorporate these two into one statement. When putting that on the number line, at 6, because there's a line underneath this, we would put a closed circle. And at 20, because it would include 20 minutes, I would also put a closed circle. So W is greater than, and it helps to use the broken down statements here, W is greater than 6, but it's less than 20. So greater than 6 would be to the right, and less than 20 would be to the left. So what I'm doing is I'm actually shading in all of this time in here. So meaning it can take 6 minutes all the way up to 20 minutes to be charged. So any time in between here, if I waited this amount of minutes, I would be charged for my oil change. Okay, let's look at another example. In the next one, it says, Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work for at least 6 hours to save enough money, but he must work less than 16 hours this week. Write an inequality to represent this situation, then graph the solution. Okay, so we can use G for Gurnaz. He has to work at least 6 hours. If you recall, at least means 6 or more, so that would be greater than or equal to 6. But he also must work less than 16, so less than does not include 16. So Gurnaz, less than 16. So once again, I'm going to put my variable down. I'll put the smaller of the two numbers to the left, the larger of the two numbers to the right. And then I just need to make sure that the symbols are facing the correct way. So since G is to the left of 16, as it is here, I can use the symbol that it is. Notice the point is facing the G, the open side is facing the 16. This one, however, is backwards in order. So I want to make sure that it's pointing to the 6 with the open side facing the G. Pointing to the 6, open side facing the G. And then of course I have to include that line underneath. So when I go to graph this, the line underneath includes the 6. So at 6 it's a closed circle. However, at 16 it would be an open circle because it does not include the 16. It has to be less than 16. So again, it may be easier to come down to this broken down piece, which I would highly recommend doing before jumping into the combined statement. G is greater than 6, meaning I would be shading this way. And G is less than 16, which means I'd be shading this way. So it's going to include any of the number of hours in between here. So 6 all the way up to just before 16, because it does not include 16. Okay, so let's look at some other examples. Example 4a says Jane can make 3 costumes per day. So far, she has orders for more than 18 costumes. Right now, Jane needs more than 6 days to make the costumes. So if you think about it, she has orders for more than 18, and if it takes she can do 3 costumes per day, 18 divided by 3 would mean more than 6 days. So Jane, more than means greater than 6 days. So to graph this, I would put an open circle at 6, because she needs more than 6, because she has more than 18 costume orders. And then I'm going to shade to the right for numbers more than 6. In letter B, it says Jane must have the orders completed in 8 days or less. Using what you know from part A, create an inequality that follows both requirements. So I want both here. So I know that Jane can do greater than 6 days, more than 6 days, but Jane also has to complete it in 8 days or less. So that would mean 8 days would be included because it could possibly be done in 8 days or less. So that's less than or equal to 8. So to rewrite this as one inequality, I'll start by putting my J down. Put them in numerical order, so 6 would go first, 8 would go last. And then just make sure that the symbols are in the right order. So in this case, the open symbol is facing the J, the smaller point is facing the 6. And in the second part, it's written in the same exact order. The J is first and then the 8. J first, then 8. So my symbol can stay the same. The point should be facing the J, open facing the 8. So now when I go to shade this in, J is going to be greater than 6, which means it doesn't include it. So that's open circle. But at 8, it could include it with that line underneath. So that would be shaded in. So when I'm shading, J has to be greater than 6, which means shade 6 to the right, and less than with the 8, so shading this way.